So we can do u substitution for exponential functions as well. Officially, we have e to the u, which u is a function. It says u let u be a differentiable function of x. When we integrate it back, we get e to the u. We can also do it for our other exponentials. So when we have a to the u and we integrate, we get 1 over the natural log of a times a to the u plus c. So let's try this a couple times. So I'm looking again for my inside function. In this case, my inside function looks like it's the 3x plus 1. So u equals 3x plus 1, which means that du equals 3 dx. So I don't see the 3, so I'm going to add it in. So we end up with 1/3 the integral of 3 e to the u dx. And then I notice I have the 3, I have my u, I have my du, so I'm ready to integrate. So 1/3 the integral of e to the, I put the u in already, didn't I? E to the u, and then the 3 dx gets the du. This is a really poor line. I should have really rewrite that. You cannot have different variables of integration. There we go. Okay, now it's proper. So we've got 1/3 e to the u plus c, and then I need to substitute in my u value again. So 1/3 e to the 3x plus 1 plus c. All right, let's see what happens with b here. So I've got, I'm going to use, looks like this is my inside function, so I'm going to try that for my u. So negative x squared, which means that du is equal to negative 2x dx. Well, I see the x dx, I do not see the negative 2, so I'm going to multiply top and bottom by negative 2. I'm going to take this 5 out front, so 5. I'm squishing the negative 2 inside, negative 2x e to the negative x squared dx, and then I still have this negative 2 out front, but I'm going to turn it to the dark blue. Okay, now we have enough to do our integration. So I've got negative 5/2, or to do my substitution, e to the u, and then for the negative 2x dx, I get to substitute in du. All right, I'm going to integrate it. So we've got negative 5/2 e to the u plus c. And then we need to substitute back in our u value. So negative 5/2 e to the negative x squared plus c. All right, let's look for an inside function, and the next one's going to look a little crazy. We're working with exponentials, so I'm going to actually use this as my inside function. So I know that this is u equals 1 over x, which is really, because I'm going to take the derivative of that, so I really should rewrite it as x to the negative 1 power. So that means that du equals, I'm going to bring the negative in front, negative x, I'm subtracting 1 off of that, so that would be negative 2 dx, or negative 1 over x squared dx. Do you see how you have a 1x squared right here? So I still need to introduce the negative, so I'm going to multiply by negative 1 over negative 1 on top and bottom, and bring this one inside. So let's rewrite a bit here. So we've got 1 over negative 1, the integral of e to the u over x squared, because I started substituting in. I'm not ready to substitute in. Let me fix that. So we've got e to the 1 over x, which I wanted in orange, All right, and then we've got for the x squared, we're using the light blue. I need to shove the -1 inside and then the dx. Now I am ready to integrate because I have everything that matches. So we have negative, I'm just going to make that a -1. -1, the integral of e to the u, and then for the -1 over x squared dx, I'm substituting du in for that whole thing. So we end up with -1 e to the u plus c. And then we're going to substitute in the u. So we have 1 over x and then plus c. I wrote way too big, didn't I? All right, we got one more in this little section here. We're going to use cosine x as the u. So u equals cosine x, meaning that du equals sine x, negative sine x dx. So I have everything except the negative. So I know I'm going to need a -1 on the top, -1 on the bottom, or basically a -1 inside and -1 outside. I'm going to rewrite by shoving that inside. So I have 1 over -1, the integral of the -1 sine x, because I shoved that -1 inside, e to the cosine x dx. All right, so we really have -1, the integral of e to the u, and then for the -1 sine x dx, I get du. And I'm just making sure, yep, I'm on the right track. All right, so equals negative, ooh, that's not the color I wanted, is it? We're not following the pattern very well. So we've got -1 e to the cosine x, sorry, e to the u, plus c. So we get negative e to the cosine, oh, that didn't change color. Substitute my u back in, so cosine x plus c.